Good afternoon, everybody. Welcome to our webinar series. Today we are joined by Mark Reich, who is our in-house expert on cannabis, and he is going to talk about operating expense strategies for when you're in a saturated market. My name is Tara Wilsworth. I handle marketing here at Prospient. And if anybody has any questions, please put them in the chat box and we'll answer them as they come up if it's relevant for that slide. Otherwise, we'll hold it until the end of the webinar and answer all the questions at once. So with that, I'm handing it over to Mark, who will do a bit of an introduction and then get going.
Yeah. Hey, everybody. So my name is Mark Rich. I'm a systems integration engineer here at Prospient. So background is I've been here about 5 years. I have my degree in environmental engineering from the University of Cincinnati and work on essentially integrating all of the systems that go into a cannabis facility for our cannabis projects and kind of help customers take ideas and put them into the real life solutions and help a lot of these projects get up off the ground and start cultivating. So drive right in.
Sorry.
So today we're really focusing on talking about just OpEx. So really what is OpEx? What does the acronym stand for? It's just operational expenses. And today, as we kind of talk about it throughout the rest of the slide deck, we'll kind of talk about it in price per pound, price per square foot. There's a lot of different ways to calculate OpEx. There's a lot of different ways to kind of talk about OpEx and different things. But for the most part, we're going to talk about price per pound, price per square foot. Even square foot can be broken up into canopy square footage or total facility square footage. We'll usually be talking about it in canopy square footage, so how much bench space you actually have, and going off of that. And so really, like what kind of makes up OpEx is there's so many different things that can go into an OpEx expense. So three of the biggest ones is going to be your electrical usage, gas usage, water usages. These are all very important to every single facility, make up a large portion of the overall OpEx expense, but can also be very location dependent. So electrical usage, you might be able to get, 11 cents per kilowatt hour in Ohio, but then, you go to New York City and it might be 19 or 20 cents per kilowatt hour. So there's a lot of different things to kind of take into account when you're designing a facility to have the correct OpEx and kind of shoot for a goal on your OpEx. But a lot of these are location dependent. Gas is super location dependent. Some facilities, the location that you're at might not even have natural gas. It might not have propane. It might not have anything for you to run that specific equipment off of. So those are all factors that need to be taken into account. Some more ones are taxes. This could be property taxes. This should be taxes on products sold. It can be, everything you buy and sell nowadays has taxes on it. So taking that into account. Property, do you own the land? Do you have a mortgage on the land, or are you leasing the land, like the facility? That can be a fixed cost that's included in the overall OpEx for a facility. A variable cost could be employees. How many employees do you have? What's the wage that you're paying them? How efficient are they? A whole lot of stuff like that. Equipment depreciation. This is kind of more on like the accounting side of things, so this can actually be factored in as a positive, but in the end, still a negative. But a lot of these, OpEx can be pretty standard things like electrical usage, but it can also get pretty in depth on the accounting side of fixed cost versus variable cost and operating income and the whole 9 yards. So, and then kind of lastly here, we have packaging. So, once you cultivate your product, how much does it cost for you to put that product into the container that you're going to sell it in? Is that the plastic jar that you sell it at the dispensary at? Or that could be, how much does it cost to take biomass and turn it and extract it into rosin? How much does that cost you in that whole process to get there? That's all factored into the OpEx side of things. Or even just a pre-roll, how much does it cost you to, grind and then stack it into a pre-roll and then put it into the correct packaging. So all of those like little minute things can be included in the OpEx, but the main ones we're really going to focus on today is going to be the electrical, gas, and just the different systems that would go into basically raising or lowering your CapEx or your OpEx. And then, so why is OpEx important? OpEx is extremely important to any facility and any business. OpEx isn't something that's just a cannabis thing. It's in every business. Every business has operating expenses. Every business is trying to lower their operating expenses if they can to get the same performance. So really, OpEx comes into on profit margins. You can get all of the yield you want, but if you have really high OpEx side, you can't still turn a profit margin. It's not a sustainable business, right? So in order to have a sustainable business, which is what everybody's looking for, you really have to be able to maintain your OpEx to where you can continue to keep your profit margins. And, on a year-to-year basis, are you able to raise and continue to incrementally raise your profit margins to make a more successful business? So a lot that goes into that, and then kind of into the maturing market side. So the rest of the webinar here will kind of talk about ways that people in mature markets can kind of lower their OpEx without, changing or going to a new facility, having new construction or anything like that. But, some really mature markets, California, Colorado, some of the oldest markets in the States. But then two other ones that are like relatively new, but have experienced the biggest aspect of a maturing market is Massachusetts and Michigan. And with these two, everybody knows that when a market first opens, you're going to get the highest price per pound as possible. Massachusetts, you might have been getting $3,000 a pound wholesale price, 4 or 5 years ago. And now you might be only getting $800 to $1,000 a pound wholesale. So really, how is it that you can lower your OpEx to stay competitive as a market matures? That's the biggest thing. That's what a lot of our clients have a lot of problems with is, if you build an indoor grow and you're operating at $1,200 a pound OpEx, but selling it at $3,000, that's awesome. That's a profitable business, but is it sustainable? When that price per pound drops to the $1,000 and you're still operating at $1,200, it's not a profitable business, and you can't keep that going. So that's kind of the big part we're talking about here. And then when it comes to competition, can be tied to like sustainable business practices, but it can also just be tied to the competition itself. If your number one competitor is growing the same quality flower as you and they're selling it at the exact same price, but you're cultivating it at $400 less per pound, you are more competitive than they are. You're going to be able to eventually sell that for cheaper, make the same profit margins as they are, and eventually kind of weed them out of the business, out of the market, and maybe potentially gain their market share. So there's a lot of things that go into this, and OpEx is extremely important. It's something that every cannabis operator should be really focused on and trying to lower as much as they possibly can. So this slide here, this one, obviously the graphs on the right we're going to be talking about here, but this one is really focused on the type of facility that you're cultivating on. And this doesn't have all of the OpEx metrics in it. The main ones we're going to be kind of talking about here is just like natural gas cost, propane cost, electrical usage to run your HVAC equipment, as well as the electrical usage to run your lighting equipment. Those are going to be like the four main factors here on this one. So more of just like a system side and systems OpEx. But really, when it comes to how you're cultivating, there's really four main ways we're going to kind of talk about here. So the first one being, outdoor cultivating. This is going to have the lowest OpEx. It's going to be the most efficient way of doing it. And then there's kind of two different greenhouse styles we're going to kind of look at here. So it's going to be a hybrid greenhouse, which is going to be basically using a pad and fan wall, taking outdoor air to dehumidify and cool your zones. And then you're going to have a sealed greenhouse, which is, in easy terms, an indoor grow, but with a glass roof on it. So all of your heating, cooling, dehumidification, it's all done mechanically. There is no bringing in outdoor air. And essentially, you're just growing with a glass roof as an indoor grow. And then the last one is just going to straight up just be the indoor grow. Most popular, the one most people are familiar with, the one that kind of started the whole industry, and the one that kind of still leads the industry on this side. So kind of talking about those two. In the graph below, so the one on the top right, that's going to be a sealed greenhouse. So that's essentially comparing, and the bottom right one is an indoor grow. So we're essentially comparing how can you take an indoor grow and an indoor grow with glass roof, which we're calling a sealed greenhouse, and compare them from an electrical usage on the system side of things. So at the end of the day, we were running the calculations on this and found that the greenhouse had about $390,000 in electrical and gas usages for the year to run these 4 systems, or basically just the systems in the greenhouse. And then the indoor grow had almost double at $730,000 a year of expenses. So it's a big difference, and you can like kind of see why, per the graphs, why the major difference is. So if you look hard enough at it, you can actually see that the greenhouse has higher HVAC electrical costs. So a greenhouse roof doesn't have the insulation that an indoor grow is going to have, so you're going to lose more heat through that roof. But also during the summertime, you also have more solar heat gain coming in. So you actually have to have provide more cooling in a greenhouse during the summertime than you would for an indoor grow because of that solar heat gain. But the major difference here, it's these green bars on this bottom graph. You can see they take up most of the entire graph, is just the lighting electrical costs. So in an indoor grow, you're supplying all of the light supplementally. There is no natural sunlight coming in. You know, if you want 1200 micromoles, you have to have enough fixtures in that area to provide 1200 micromoles. Whereas in the glass house greenhouse, you know, if you want 1200 micromoles, you might only have to supply 400 micromoles to get to that, because you might have 800 coming in through the sun. So that's going to help save you money on your OpEx side. And basically, you can see from these 2 graphs how big of a difference that really can be. And this doesn't factor in ROI or like break-even points or anything like that. This is strictly just an electrical and gas usage for a greenhouse versus an indoor grow. Nothing to do with yields and grams per square foot or anything like that. And yep, go ahead, Tara.
Sorry, I didn't mean to jump in there. What is the orange? I think the blue is HVAC, but what's the orange? I can't read the letters.
The orange is natural gas costs.
Okay.
And we have propane costs in there, but for this one, basically the equipment we were utilizing for it all was able to go off of natural gas. Natural gas is going to be a little bit cheaper than the propane costs. So, but yeah, this is also done off a 25,000 square foot facility in the Midwest, maintaining a somewhat lower DLI around 35 with HPS lights. And you can see the metrics down there that were basically used to account for these costs on the graph. And then now to kind of get more into the exact technical side of some of the things that cultivators can do to lower their OpEx, especially in mature markets. The first one is going to be lighting efficiency. So how are you supplying supplemental lighting? You know, are you doing it efficiently? Are there better ways to do it? It's kind of going to be what we're looking at here. And the first one we're going to be doing is HPS versus LEDs. Kind of the tale as old as time. Everybody's done their own research. Everybody, you know, is pretty familiar with this side, but how much have you like really factored it into your like sustainable business success? You know, if you're using HPS lights versus LEDs, you're going to have that higher OpEx, but it could also be location dependent. So basically, like the 30,000 foot view of this is HPS lights take about 1,000 to 1050 watts to give off about similar light intensities as a 630 watt LED does. And it doesn't take a whole lot of math to really show that if you're running, you know, 100 630 watt LEDs versus 100,000 watt HPS lights, obviously it's going to be cheaper to run with the LEDs. You're going to have lower OpEx. This is going to help a lot with your facility, but there's also some things about it, you know, with the heat, the HPS light's going to give off significantly more heat in that zone than the LEDs are going to give off. So are you in like a really cold climate where this extra heat doesn't necessarily like hurt your business? Or are you in a really hot, dry climate where this extra heat makes you have to, you know, add more capacity to your AC units? Or if you're running RTUs or a 4-pipe system, you have to have more cooling capacity to get rid of even more of this heat that the HPS lights are coming off. You know, and if you go through a pretty in-depth analysis of it, there's a lot of money being lost on the OpEx side from people not giving this enough fine detail and enough consideration on really making this change. And if you're in a mature market and you're currently growing with HPS lights, you know, it can be really easy to retrofit that HPS system into an LED system, you know, and you might be able to get rebates for that. You know, the CapEx side of adding LEDs in that facility might not be as harsh as you think it might be. There's a lot of rebates coming out that can help with this. And And also with it, your profit margins might also be able to increase because these LEDs might help you increase your yield, by 15 to 20%, while also lowering your OpEx side. So everybody kind of has their own way of doing it, but it's something that having that retrofit and that distinguishing between HPS and LEDs can really save a lot of people money. And then like fixture longevity with it. So, what are your HPS lights rated for? Are they rated for, is a bulb rated for 5,000 hours of light, or is it 10,000 hours of light versus an LED? Is it 10,000 versus 50 versus 100,000 hours of lights, or of light? So really, like, this goes back to the equipment depreciation side of things. If you're having an HPS light, that bulb's going to burn out and it's getting dimmer, which again is going to affect your yield, but keep the same OpEx side. So are you replacing that bulb every harvest, every 2 harvests, every year? How much are you spending to replace those bulbs every year? Whereas an LED, you don't have to replace bulbs. So that's another saving on the OpEx side. And that's not saying one is best for one scenario or the other. It's just something that needs to be accounted for when calculating your OpEx and kind of doing your OpEx for a new facility. The CapEx versus OpEx side, so we kind of just talk about most of the OpEx side. The CapEx side is obviously LEDs are going to be more expensive than HPS lights, anywhere from 2.5 to 3.5 times more expensive. So really looking at what is the payback period of going, if you're building a new facility and you want to put LEDs in there, what's the payback period to put these LEDs in there? Does it make business sense to do this? So something you kind of need to ask yourself. And if you're kind of worried about the CapEx side of LEDs, really looking into the rebate side, the rebate side might make it to where LEDs are the exact same cost as HPS lights. So why wouldn't you do that to lower your OpEx side? So a lot goes into this, a lot to take into account with it. There's water cooled fixtures. This is kind of one of those new technologies that's kind of emerging. So essentially water cooled fixtures, they're almost always LEDs. So instead of having these LEDs put the additional heat back into the zone, essentially you're running water through it, capturing that heat and then bringing it back to wherever you may want it to. So that heat doesn't go into the zone, causing you to have extra, cooling capacity. And then you can actually use that heat that's contained within the water. You can use it irrigation preheat. You can run it back to your HVAC system. There's a lot of different things you can kind of do with that. It can help with the efficiency of your lighting system a lot. And just another thing, it's going to have a higher CapEx than just a regular LED. But at the same time, what's the payback period of it? Yeah, and that's kind of like the 30,000 foot view of the lighting efficiency and how it can help you a little bit on the OpEx side.
What about the fixture integration? That's the last bullet point. I didn't think you spoke about that.
Oh, yeah. So fixture integration, kind of correlating this to OpEx side. So if you are growing with LEDs and say you're in a greenhouse and you only want to have your LEDs at 50%, you can dim them down. You don't have to run a checkerboard scenario where you would with HPS lights, where your light intensity isn't uniform across the zone, causing more problems with the overall crop. Versus LEDs, you can have all of your LEDs on at 50% dimmed and still have uniform light intensity across the entire zone. All your crops are receiving the same light, whereas the checkerboard system, you might be getting, directly under the light might be getting, say, 1,000 micromoles, and 4 feet to the left is only getting 600 micromoles. So having the dimming capabilities with LEDs is super helpful on the OpEx side as well. And then, so sustainable water practices. There's a lot that goes into this one, so we'll kind of keep it high level again. But water, when we're talking about sustainable water practices, we're mainly going to focus on the irrigation fertigation side of things. And with this, basically, how to begin it is, how are you getting water to your facility? Are you pulling off of the city water? Are you pulling off of a well? And then into that, what is the how is the makeup of your water? Do you need to treat it with RO? If you don't need to treat it with RO, there's no reason to run it through an extra system that's going to cause pretty sufficient like efficiency losses in an RO. But if you do, have you designed it around the RO recovery rate? So like an RO can be, some of them are upwards of 90% efficient. 90% of the water you put in, you get out, but then some of the other cheaper systems, you might be as low as 40% recovery rate. And if you're at 40% recovery rate, that's 60% you're paying for all that water to go through your system, but you're not getting anything from it. So have you kind of looked into that side of things, and like how much money are you really losing on your water bill if you have an inefficient RO or just, pre-injection treatment in general? And then another thing with ROs is they're rated for specific feed water temperature. So if it's rated at 78 degrees for a 90% recovery rate, and your feed water is at 60 degrees, you might be all the way down to 60, 65, 70% recovery rate on that RO. So if you were able to heat up that water and save yourself all of that extra wasted water, does that make business sense? Does that help you lower your OpEx in the long run? And those are just some of the major and minor losses included in pre-injection water treatment. Really making sure that you're not just wasting thousands of gallons, especially on some of these facilities that might be using 20, 30,000 gallons of water per day just to irrigate. And now onto the watering rates. So do you know what your watering rates are? Do you know exactly to the exact milliliter how much water you're feeding each of your plants? Do you have a way of tracking this? Are you hand watering? And how much are you actually over watering? Every single facility is going to have a leachate percentage of runoff, but are you at 5% or are you at 50%? If you're hand watering it and you're hand watering a plant, somebody calls you and you kind of lose focus, and all of a sudden you see 4 or 5 gallons of vertigated water on the floor. Not only did you just waste the 4 or 5 gallons of water, but you also wasted all the nutrients that you had put into that water. So that's like a double inefficiency loss. So really knowing how much you're watering, being able to dial that in is going to be pretty significant. And then based off of that, once you have leachate, what are you doing with it? Are you putting it straight to the drain? Are you recapturing it? Are you recapturing condensate off of the HVAC units in the facility? Those are two big things that if you're able to capture these and treat them efficiently in order to reuse them again, this can also help lower your OpEx in general. But there's also some caveats with it. Leachate recirculation, you might be able to reuse some of the nutrients you've already introduced to the plant and then captured in that runoff. But at the same time, it's not the cheapest systems to install in a facility. So again, really looking at the payback period on these. Condensate significantly cheaper to treat than leachate recirculation. And if you're not capturing condensate, how much water are you wasting a day by not capturing this? And you can do it relatively cheap. So if you can do it cheap, and the payback period is 8 months to a year, would it make sense sustainably as a business to implement this and keep it going? That's kind of the CapEx and the OpEx scenario of it. Every single one of these CapEx and OpEx scenarios is going to be unique for each facility, but they're all worth the look if you're trying to stay sustainable throughout the entire longevity of your market. And then HVAC efficiency is next, and this is by far the most important one. We could honestly probably have an entire webinar series just about HVAC efficiency and how you can lower that and help your OpEx. So we'll just talk about a couple things, just a couple high-level points. But the first one's going to be just cultivation structure, and what structure are you cultivating in? If you're in an indoor grow, are your sidewalls and your roof rated at R30, or are they rated at R8, R12? How much heat are you losing within your zone to the outdoor environment? Is this something that if you're looking at it from a new build perspective, have you looked at how much money you'll save by buying a facility that has higher insulation? How much is that going to save you in 10 years down the line? So that's going to be a big one. Same with greenhouses. What's the R value of a greenhouse glass roof? It's going to be lower than an indoor grow. And is this something you've accounted for? Versus polycarbonate, it's going to have a higher one. So But the big one here in the HVAC side of things are if you have independent systems, so if you have an RTU versus and a dehumidifier in the zone, are they working against each other? If they are, it causes massive operational inefficiency. So, if your RTU is cooling your zone down to a level below your set point, well, that's going to kick your dehumidifiers back on because your relative humidity is now raised, and you're basically utilizing that dehumidifier, paying the operational expenses to run it to take out additional water when really you didn't need to. All it was your temperature set point wasn't right, which caused your relative humidity to go up, and now you just have this positive feedback loop of one system working directly against another system when really all you needed was one system to turn on instead of both of them. And HVAC equipment is pretty bulky. They take a lot of electrical usage to operate. It's not just like a standard irrigation pump that might be a half horsepower pump. If you're running an electric chiller when you don't really need to, you are throwing money down the drain. So really making sure that every single system within the zone is integrated correctly, and exactly what the relationship between these two are. It happens the most when you have an RTU and dehumidifier system. It's really something that's not exactly the easiest thing to work against. A lot of these equipment and systems kind of have self-controls on them, and they're not communicating with each other. If you don't have them communicating to an overall master control, there's really nothing you can do here, and you're just going to have to deal with the operational inefficiencies unless you add a master controller to have these discussions with them. Lastly, or I guess not lastly, but just in the economizer mode here, if you have an outdoor air handler to supply all of the zones with the correct environmental air makeup, are you able to run this on economizer mode? In economizer mode, what we would kind of call that is if you're growing in the Midwest and it's the middle of the winter time, and all you have to really do to utilize that outdoor air is heat it up before you put it in the zone. You don't have to do any dehumidification. Are you able to pull directly from outdoor air instead of indoor air and just heat that up for a third of the price that it would be to bring indoor air that's too hot and too humid, take both of those out, and then reintroduce it? Can you just pull that outdoor air, heat it up, enter it into the zone, and it's perfect? Or if you don't have this, you might be running your HVAC system at 100% capacity in the middle of wintertime, versus if you're running economizer mode, you might be running it at 15 to 30% capacity during these months. And that's just more savings on the OpEx side. Something really, really important to take into account. It could be 4 to 6 months out of the year. So really important on that side. And then VPD relationship is a big one. And this is one of those that, everybody has their special sauce when it comes to set points and exactly what they're looking for. But really what it comes down to is if you're in the last 2 weeks of flower and you're trying to shoot for 60 degrees Fahrenheit and 40% relative humidity, what is the operational expense associated with that versus, keeping it at maybe bringing it down to 75 and 50? How much more energy do you have to put through your HVAC unit to get to these lower set points in order to be in that VPD range, versus if you were still within a VPD range but just at a higher temperature and higher humidity? What is the correlation? How much more does it cost you to get to there? And what is the yield benefit of getting down to the lower ones? It might pay itself off. You might be able to get better yields. You might be able to get better product by getting to those. But if you're not, why spend the extra operational expenses to get down to there when you can still be within your VPD range at a higher percentages up there, essentially? And the reason why HVAC is so important when it comes to OpEx is because it's the largest portion. Depending on how you actually calculate your OpEx, if you're including, your property and taxes and everything in it, could be anywhere from 30 to 35%. But if you going based off just the graphs above, it could be 50 to 60% just on the HVAC side. So really important to make sure that you have your HVAC dialed in and that you guys are really focusing on this side because this is where the most amount of money can be saved. And then lastly here, we got SOPs, data tracking, and yields. So first we'll go with SOPs. Everybody has their own SOPs. They're starting to become a little bit more standard in the industry, but really, are your SOPs creating operational inefficiencies? Like, is this something you've looked at from a third person point of view? Have you looked at, do you have multiple employees overlapping on tasks? Is one employee doing one task and isn't relaying it to another employee, so then they go and do the same task an hour later, and you're paying these employees a relatively good wage? That's affecting your OpEx. Are they not talking to each other? Are they not talking to a manager? Like if one employee goes in, and sees an aphid on one plant and doesn't tell the person who's supposed to go in and remove that aphid, then you lose crop, which isn't going to necessarily affect your OpEx, but it's going to affect your profit margins because your yields at the end of the day are going to be lower from that side. So, having SOPs in place that are solid and like well respected and everybody understands them in a facility is going to help it move so much more efficiently. Having everybody on the same page is going to just help one another. It's going to make your facility significantly more efficient, and at the end of the day, it's going to lower your OpEx. And then getting to data tracking here. So a lot of facilities are starting to kind of turn to this with more of a keen eye, and it's really just, are you correlating your yield to environmental set points throughout a plant's lifestyle? Are you able to replicate your yields? If you were able to get 98 grams a square foot in December, are you able to get 98 grams a square foot in the middle of July? And if you're not, do you understand why you're not able to get that? Do you have the data to support why your yield dropped from 98 grams a square foot down to 84 grams a square foot? Having this data tracking is really going to help with replicating yields. It's really going to help with just making sure every single metric is in there. And when I'm talking about data tracking, it could be as basic as temperature and humidity in the zone, but it could also be as complex as, soil moisture content, DO within the water you're irrigating, ORC within the water you're irrigating. There's so many set points in a facility you can keep track of, and there's never going to be data that you have that you can never use on anything. It's always good to have as much data as you can to tie back to yields and basically go through the operational process and throughput of understanding what metrics you change that were able to help you create more yield. And really, like, if you have an air purification unit in there, like, do you actually know if this is doing anything in the zone, or do you just put it up on the wall, let it take electrical usage, and you've never really seen a difference on it? And if it's not making a difference, then why have it in the zone? If this is just causing you more money to operate, if it's not actually making a difference, there's no reason to have it in there. And data tracking can always be tied back with SOPs. SOPs are really going to be what kind of drives the data tracking. And again, you're going to have employees on board with it. You might have to have a third party system about like task management with it, but there's a lot you can do with data tracking that I think would be super beneficial to not only help lower OpEx but also increase yields. And then yields itself, we've been kind of talking about it, and yields itself doesn't necessarily have a direct correlation with the OpEx unless you look at it from a price per pound. But if you are losing crop, you are essentially losing money and you're losing profit margin, which is going to affect the overall sustainable business aspect. So not losing any crop is always going to produce you more revenue, always produce you more profit margin, which at the end of the day is exactly what you're looking for. And lastly here, just kind of a couple questions, like, if you could cultivate 30% more yield with the same operational expenses, like, what would that do for your business? Does that make you gain more market share? Does that allow you to, go with that phase 2 or phase 3 expansion in the year? Or even if you could cultivate the exact same amount of flower each harvest, but operate at 30% less or even 15% less, like, what does that do for your business? Does it allow you to become a bigger player? Does it allow you to, implement a data tracking third-party system, which then lowers your OpEx even more? Just a couple questions to kind of look at with that. And Tara, I think that is the last of the slides here.
Okay, great. If anybody has any questions, this is Mark's information on the screen right now. Mark is available by email or by phone. And we haven't got any questions in the chat so far. So if anybody does have any questions after the fact, you can email Mark directly, or you can just email info@prospiant.com. I monitor that mailbox as well. So with that, thank you very much, Mark. I'm sure you need a drink of water now after all that. Yeah. All right. Well, thanks very much. It was all really good information. I appreciate it.
Thanks, everyone.
Bye.